Hey guys, today we're going to be talking about how to simplify trigonometric expressions. I'm sorry I don't have my webcam today. Let's get started. When we're talking about simplifying trigonometric expressions, we mean to rewrite it as a numerical expression or in terms of a single trigonometric function. What I mean is, like, I'm either going to get a number or I'm going to get a product of a single trig function. Let's see what that looks like. We're going to be using several strategies. I'm going to label them 1, 2, 3, 4, and 5, just for the sake of expediency, but I'm going to be saying them out loud. The first strategy, and probably your most useful strategy, is to rewrite using the reciprocal and quotient identities. Remember, those are the very first two boxes on your reference sheet. So let's take a look at this first one. The first one says the secant of theta minus the sine of theta times the tangent of theta. I want to simplify this into one trig function. Let's see what that looks like. So I'm going to rewrite this using reciprocal identities. So I'm using strategy 1 here. So the secant of theta is 1 over the cosine of theta. That's a reciprocal identity. And then minus the sine of theta times the tangent of theta, and tangent of theta from my quotient identity is the sine of theta over the cosine of theta. Even if you have no idea what to do on your trigonometric identities, a good first step, if you don't know anything else to do, is to turn it all into sines and cosines using those reciprocal quotient identities. Now you don't need to go in this order. You could look for your Pythagorean identities first, or any of these. We're going to see when each one is appropriate. So I'm going to combine these. Sine of theta times the sine of theta is the sine squared of theta over cosine theta, and 1 over cosine theta. And then I'm going to use my third strategy, which is combine fractions using common denominator. Since these both have cosine of theta, I can combine them into 1 minus sine squared theta over the cosine of theta. And then I'm going to use a Pythagorean identity. You might say, well, that kind of looks like a Pythagorean identity, 1 minus sine squared theta. But when you actually go back, you see that none of these actually have the 1 minus sine squared theta. So it might be a good idea to add some algebraic transformations to this. And those are that the 1 minus the sine squared of theta is equal to cosine squared theta, and 1 minus the cosine squared theta is equal to sine squared theta. Those are two pretty good ones. Additionally, you can also add that the secant squared of theta minus 1 is equal to the tangent squared of theta, and then that the secant squared of theta minus the tangent squared of theta is equal to 1. Lastly, you can do the same thing for this third one, and that is that the cotangent squared of theta minus the cosecant squared of theta is equal to that the cosecant squared of theta minus the cotangent squared of theta is equal to 1, and that the cosecant squared of theta minus 1 is equal to the cotangent squared of theta. Now that we've had that aside, let's go back. 1 minus the sine squared of theta, well, we recall that that is equal to the cosine squared of theta. And that's the cosine squared of theta over the cosine of theta. And then that was strategy 2. Look for Pythagorean identities. And, well, this is just now a fraction that simplifies pretty easily. Because the sine squared of theta, or the cosine squared of theta over cosine theta, well, that's just something squared over itself. I'm just going to get equals to cosine of theta. You may be able to tell now that this is going to be one of our more difficult topics. Let's look at this next one. Let's see if I can do anything with rewriting stuff using our reciprocal identities. So, the sine of theta plus the cosine of theta, the cosine of A plus the cosine of A, and then the tangent of A, we recall, is equal to the sine, again, is equal to the sine over the cosine. So times the sine of A over the cosine of A. Well, hey, this one's basically done for us, because the cosine of A and the cosine of A down here cancel out. And so I'm left with the sine of A plus the sine of A, or 2 times the sine of A. Let's keep going. Here, I have cotangent squared minus cosecant squared. Ooh, I'm seeing two square things. When you see two square things, or two square trigonometric functions, or maybe a square trigonometric function with a 1, it's best to check our Pythagorean identities first. So on this one, I only ever use strategy 1. But on this one, I think I'm going to start out with strategy 2. And I'm going to see if there's anything that relates cotangent squared with cosecant squared. Oh, and there is right here. Remember, we just discovered that one. But notice how this is in the reverse order. This is cotangent squared minus cosecant squared, and this is cosecant squared minus cotangent squared. Well, a really nifty thing that we can do is that if we just we can reverse the order of subtraction by multiplying by -1. So -1 times the cosecant squared of u minus the cotangent squared of u. These two things are equal. I could change the order of subtraction by multiplying by -1. Or really what I'm doing is I'm factoring out a -1. So this is similar to strategy 5. So I'll also include that, because I factored out a -1. And lastly, cosecant squared of u minus cotangent squared u, cosecant squared minus cotangent squared is just 1. So I have -1 times 1, which is just equal to -1. Let's do a few more. Okay. I don't see a lot going on here. I mean, if I turn these both into their, if I turn both of these into their quotient identities, I can eventually get to where I'm looking for. But it's going to take us a lot of work to do that. So maybe we could try simplifying things first. Because I see that this is sine over cosine. Okay, well, hey, that's a good place to start. Because sine over cosine is tangent. So I get the tangent of x times the tangent of x plus the cotangent of x. And so that was my first step, right? I used my quotient identity there, because sine over cosine is tangent. And now I'm going to distribute. And so tan of x times tan of x is tan squared of x, and the tan of x, and then plus the tangent of x times the cotangent of x. We might recall that the tangent and cotangent are reciprocals, which means that if I multiply these together, I'll get 1. Let's take a look at that, because so it's just the tangent squared of x plus the tangent of x times 1 over the tangent of x. Well, look at that. Those cancel out, and I'm left with 1. So I get tangent squared x plus 1. Oh, look, it's a square and a 1. Tangent squared of something plus 1 is equal to secant squared of that something. So I just get the secant squared of x. We have 2 more. Ooh, look at that. Let's see what technique we can use. I'm thinking that we can combine fractions here, but I can't combine fractions unless I have a common denominator. So I'm going to take this, and since that's over 1, I can get a common denominator by multiplying the top and bottom by the cosecant of theta. Cosecant theta times cosecant theta is the cosecant squared of theta over cosecant theta minus the cotangent squared of theta over the cosecant of theta. And then I can combine these, so I get cosecant squared theta minus the cotangent squared theta minus the cotangent squared of theta all over the cosecant of theta. And if we recall, the cosecant squared minus the cotangent squared is just 1. I don't even need to reverse the order this time. So this whole thing, that's just 1 over the cosecant of theta. And from my reciprocal identities, 1 over the cosecant is just sine. And so now I have that in terms of just a single trig function. Do you think you can make it through one more? Our last strategy is to break fractions apart. And so that's what I'm going to use right here. If I turn this cosecant of theta beta minus the sine of beta over to cosecant of beta, I can turn that to 2 fractions. Into cosecant of beta over the cosecant of beta minus the sine of beta over the cosecant of beta. Well, that's just 1, because something over itself is 1. You know, they cancel out. And over here, I have that the sine of beta over cosecant of beta. I know that sine and cosecant are related because they're reciprocals, but they don't cancel out. We need to resolve them, maybe using our reciprocal and quotient identities. So again, I'm using strategy 1 here. It's my most used strategy. That next to the Pythagorean identities, which I use a lot as well. I have 1 minus the sine of theta, so sine of beta over 1 over the sine of beta. And so that's a division thing. Well, if I'm saying the sine of beta divided by 1 over the sine of beta, that's the same thing saying the sine of beta times the sine of beta over 1. Well, hey, that's just the sine squared of beta. So I get 1 minus the sine squared of beta and I can return back to my sheet. This is a really useful sheet. I return to it all the time. And I get 1 minus the sine squared of beta is equal to the cosine squared of beta. So 1 minus sine squared is the cosine squared of beta. So in just about 15 minutes, I resolved all 6 of these into a single trig function or a number. If you have any questions, feel free to leave them in the comments or to ask me in person. Thanks, and have a great day.